Okay, so we saw some examples from our previous videos and how to use the Laplace table. We've already learned this. Okay, so we are we want to know how to use the Laplace table to solve these questions. So this is the first question, the second question, and the third one. So these are the answers for the questions. So let's solve the first one and see how we can use the table. So s over s squared plus 6 is the question. So we just link it to the table, as we already know from the Laplace table, is that whenever we have cos beta t, we are going to get s over s squared plus beta squared. So we know that this is a kind of this, okay? It's a kind of cos beta t. So just, you know that your beta square is equal to 6. So the beta will be root 6. Because to find the square root of this side, find the square root of this side, you're going to get root 6. So here, your cos beta t is going to be cos root 6t. Okay, very, very simple. Okay, so let's see the question 2. 5s over s squared plus 1 all square. So that's the question 2. 5s over s squared plus 1 all square. Okay, so as we already learned that Laplace of t sine beta t is always 2 times beta s over s squared plus beta square all square. So it's just very, very simple. It's just application. By using the Laplace table, you are good to go. So you know that this is just a kind of this. Yes, so it's a kind of this. Okay, so we know that here the beta is 1. The beta square here is 1 square. So it means my beta is what? 1. So when you make substitution, you're going to get 2 times 1 multiplying s over s square plus beta square, which is 1 all square. Okay. But when we get this, we are getting 2s over s square plus 1 all square. And this is not the same thing as this. Okay. So Laplace of the whole of this 2s over s square plus 1 all square will give us t sine t or sine beta t. Here the beta is 1, so t sine t. But because 5 is here, we choose to multiply it by a fraction, say 5 over 2. So the 2 here cancels the 2, so that we get similar or get the same thing as this. So instead of 2s over this, we just write t sine t. Then we multiply by 5 over 2. So we are going to get 5 over 2 t sine t. Okay. So that's why they had 5 over 2 t sine t. Okay. So let's see the third question. We have s plus 1 all over s squared minus 9. So this one we just separate it. This one is the same thing as s over s squared minus 9 plus 1 over s squared minus 9. Okay. So find the Laplace inverse of this, find the Laplace inverse of this, and add them. That's all. Laplace inverse of s over s squared minus 9 is just, it's a kind of this, something like this. S over s squared minus beta beta all square, beta square. You know that whenever you find hypo or hyperbolic function of cos beta t, you are going to get hyperbolic function of cos 3t, cos 3t. Okay, so here the beta here is 3, because you know that beta square is equal to 9, so it means your beta will be 3. So we know that cos beta is here and here is 3, and it suits this. So we are going to get cos 3t. It's simple. Okay. And also Laplace inverse of 1 over s squared minus 9. You know that this is not s, it's 1, it's a constant. So it relate to signs, because the signs here will always have the constant or the beta to be at the numerator, and the s square minus beta square 2 at the denominator. So whenever you see something like this, let your mind tell you that you are going to get something like signs. Okay, so that's what we are doing here. But because we know that my beta is 3, you are going to get sine 3t. But here is 1. But the beta supposed to be 3 because you know that my beta is 3. So my beta, the numerator here supposed to be 3, but here the question it was 1. So what do we do to make the numerator 3? So that's the question we ask ourselves. So we just bring 3 on the numerator, then we just multiply it by a fraction 1 over 3. So in the actual sense, the 3 there cancel the 3 here, so that you get back to 1 over s squared minus 9. And you know that 3 over s squared minus 9, you are going to get sinus beta t, which is sinus 3t. But because 1 over 3 is multiplying, you are going to get 1 over 3 sinus 3t. Okay, so we just add them. We had this and we also had this. So therefore, the final answer would be this plus this. We are going to get cos 3t plus 1 over 3 sines 3t. Okay, that's why they had cos 3t plus 1 over 3 sines 3t. Okay, so okay, we can also try solving it by finding the partial fraction and other stuff. It's very nice. That one too is cool. Yeah, I've also tried that one and it worked. Okay, so that's basically what we will be doing. Okay, thank you very much.